Major news. So last week we were at NFT Tallinn in Estonia. That was great. We've got, he's the regulator for anti-money laundering in finance. This one is the head of the entrepreneurship. This guy right here. This guy's a lawyer who works in blockchain in Estonia. This guy back here is head of the national bank. And we're all chatting about policy in Estonia and the Nordic area, the Baltics, and what's going to get regulated, what's not, how do you navigate the regulation, what type of companies are being attracted to the scene. So just a great talk. I met this guy right here 3 times, 3 different panels. So I hosted 2 of them, someone else hosted the 3rd. Just kept running into this guy, this Matisse. So what a great crowd. Thank you for NFT Tallinn for setting this up, industry, government, great stuff. Pretty hard to get there, terrible weather, but definitely worth it.
Super Mario, we've got Sue in the house, the original square. And
DT says hi. Tedesco says hi.
Hello.
He's on these calls.
DT. Oh, hey, Daniel.
You don't say people's names. They say their name.
Oh, sorry, DT.
Oh, hey, Daniel.
What's up with Wolf Game? So ignore what people think they want and start building your GitHub profile. That is how you get hired. Thank you. Yes. Okay, this was a stake unstake thing. SafeTran. Do I regret putting safeTransferFrom in ERC 721? No. Yes, but no. That was a critical point. Like, do we really want to have this things calling other things when you transfer tokens? And it sucks. I mean, we totally shouldn't have this in there if this was the best standard you could have. But if we didn't have this, politically, it would not have passed with unanimous consent. We would have multiple standards. This is a major point of contention. So what we're talking about here is safeTransferFrom. But we got a little dangerous things going on here, such as Wolf Game, which got smacked. So what happens is you send a token to yourself, and when you receive the token, then you perform these actions, which are reentrancy.
Super Mario. Super Mario.
Okay, here we go. I think this might be it.
Oh, wow.
I hate this website. There we go. Here's the line. So, you need to use the check effects pattern. Let's go read the documentation on this. This is the code you need to memorize, top to bottom. Get the number of shares, set the shares to 0, transfer the shares. That is the line of code, in that order. Got to know these things. Let's compare to what they did. Okay, checking, stake equals barn. Okay, great. Then they verify, great. Then they transfer, then they delete. That's the problem right there. Clear as day. Down here, so here's the transfer. So this is where the reentrancy can happen, is the transfer. So we're checking, we got the require, good. Then we modify something, we change something, then we transfer, which modifies the total staked. And then we delete it down here. Pack indices. Is that really where it's? Yeah, it's here. So this is where it's read from memory. Stake equals something, pack indices. And then here's where it's deleted. Delete pack indices. Done. That's where as soon as you see this violation, you're done. I just wanted to walk you through what it looks like to find that bug. I know this is on a call right now. We're not doing like a live security audit, but we just want to quickly find what is the thing that's wrong. And then, once you've found it, you pretty much can take your time and then pivot around the violation to go hack something. You can hack something, you just don't know what it is exactly. In this instance, you're probably going to do a lot of minting, or if you've staked one thing, if the staking gives you yield or whatever it gives you, maybe you'll get multiple yield, or whatever benefit of the stake thing you get, you'll get it as a result here. And that's it. The reason why is because when you set the variable, it will be like barn a equals 5, and then when you delete it, it's like delete a equals 5. The problem here is that this is idempotent. So if this is what they're expecting, but then this is actually what happens, the code runs because it's set, it is reset, that's idempotent, and then it's deleted. So it's expected that every insertion will be followed by deletion. And so this is 2 insertions and 1 deletion. Does that make sense, saying it that way? The idempotence problem here? The reason I want to share it like this is because reentrancy is something we totally need to understand. It's kind of specific for blockchain just because the control flow is unexpected, but in programming in general, you should understand this concept because of reference counting. So in reference counting, we would do something like this. And then we would have so this is what you would use with a reference counting application. And then here, if there was a reentrancy, you'd get something like this. So the first thing would be called twice because of reentrancy, and then the second would be called once, and then the assertion comes, bang, that fails. Because idempotency in the setting and the deleting, this is why the reentrancies don't get caught at the blockchain level. Comments, 2 comments on Ethereum magicians and cat herders. What are these groups? Are they good peeps? Yes. Fellowship of Ethereum magicians is, you can see, okay. What it used to be was this chat room for people that are tangentially involved in Ethereum. So they're not core devs, but they're core dev wannabes. So back in the day, they were talking about like EIPs related to, core EIP stuff. And then because this community is really about applications, they lost control of their community, and now it's just overrun with ERCs. Now the cat herders is a very specific thing. So the cat herders started also as a result of some initiatives from ERC 721. What happened was the EIP process, which is it here, is how you create standards for Ethereum, some changes to the client or some changes for application standards. And so here's all the standards. And so for ERC 721, when this came out, I was involved in the technical part, but also some of the, social part of this. And we really needed a process here in order to get standards passed, which we didn't have before. So part of getting ERC 721 done was creating, it's called the 2-week, the last call, the 2-week last call. So this was a major change in the process, and I've been involved in a lot of changes in the process. So what happened is that these changes to the process were coming from me, who I'm not a core developer, which is the whole point. And the core developers and the editors and the powers that be for EIPs needed a way to get high quality ideas, not a lot of static, so that they could make these decisions on how they want to change this process. Leadership formed around this, and so basically a lot of the changes that were coming in early 2018 and beyond turned into a project, which is now Ethereum Cat Herders. And then anybody who's not on Vitalik's payroll is the community, who has no power. So you've really got to stir something up in order to change something, And that's what was done with Ethereum cat herders. It's really difficult in this community because these people are not really paid, like these core contributors are not really paid. They have authority, but they really are not getting any money for what they're doing. So it kind of sucks. Should that? Okay, that's a good one. Okay, let's move that one up. Layer 0. Interoperability that actually works. I've heard that almost as many times as I heard about Carbon Marketplace. Chainlink and band. Additional layer via open layers. This is every one of these is the same. I don't see any words here different. One does not, and then they're going to be like, "Oh my God, there's so many bridges. What do we do?" We can solve any problem in computer science with one level of indirection, except for too many levels of indirection. So you got all these different networks, and of course, there's only like 2 that matter. And then you've got bridges for each and every pair. Make bridges. And then, of course, there's no tokenomics in that. That's not cool enough. So then what people are doing is like, oh, you'll see this diagram everywhere. And they're like, we're going to make this bridge like this. And we're going to do one of these things. We're going to connect this to this. And we're going to connect this to this. And so all the bridges are going to connect to this thing. So this one only needs 4 connectors, but this one needs 3 times 4 divided by 2. And they're like, wow, this model scales. In computer science, they taught us that, we should minimize, complexity. And what they did is they created a new blockchain. And of course, that is a token. And then there's a strong incentive for anybody to build anything that requires a token. So this is the type of solution that gets built all the time. And this is exactly how a lot of bridges work. If you're running 2 different systems that are not related to Ethereum, this is a centralized problem. And so you're going to get hacked eventually in one of these scenarios. There's going to be some type of time-locked hashing across these 2 networks. You're going to have some type of a bridge. So you're going to bring something from Ethereum to Bitcoin, vice versa. Because you cannot validate an Ethereum transaction on Bitcoin, you either need to have some type of a staking and an oracle, or some type of smart contract on both chains, and then you have to somehow know which transactions were run on each side, and there's going to be some type of time delay attached to staking. So here's how you attack this. A is you fork Ethereum mainnet, and then you trick the bridge into thinking that the fork is authoritative when it's not. It could be a private fork, and then use it to release your tokens over here that you still have over here. So you would have Ethereum where you own the token, then you make a fork, and on the fork you tell it to send the tokens to the bridge, and then on the other network you receive the tokens, and then the bridge thinks it's connected to the fork, and then you kill the fork, and then you've got the tokens on the bridge network, and you've got the tokens on Ethereum mainnet. Now you've got double the tokens, you've hacked it. And this can be easily worth 9 figures. The second way you can do it is you can attack one of the 2 networks. This is actually the most expensive way. Nobody's done this yet. Somebody did this for Bitcoin. Somebody did run a 51% attack against Bitcoin for a little bit. And so you would attack one of the networks so that the network's down. This is slightly different than a fork attack, because the fork attack you could use an eclipse or other way to get the validator to read your nodes. This is even easier if it's a decentralized application, because decentralized application runs on oracles and staking, and you could just buy those tokens and stake yourself, and you can guarantee success with your fork. And this is even easier with proof of stake instead of proof of work. In proof of work, you actually need to spend money to make these blocks. Proof of stake, you don't have to spend any money. So that's a different thing. You can hack the oracle itself. This is what happened with Ronin. It was a 9-node network. You just hack 5 of the nodes, you're done. And then also, the people that build this network own all the tokens. You're leaving that out. Like they only had a public sale with 10% of their tokens. Who owns the other 90% of the tokens? They do. So they could just steal you. We haven't seen a lot of rug pulls. I would love to see more rug pulls from bridges. So the bridge, you know, they have a white paper. They're like, we're going to make it, you know, $1 billion. They sell 10% of their tokens for 100 million. They've got the other 90%, and they could just rug pull it by getting more than $1 billion assets under management, and then just use their voting to upgrade the contract or some bullshit like that, and just take all the assets. And of course, you could do that all at once, like, and it's gone. So all of these things, you know, think of how much community and decision making is involved in Ethereum, and they make regular releases. Think of how little is involved in Bitcoin. They don't make regular releases. Think of those two type of communities, and they manage, you know, many billions of dollars. Okay, now compare that to a bridge, which is run by like a couple people and is responsible for a lot of money. Right, it's a much better attack target. You don't have all these people reviewing it. It's changing all the time. One person probably has the deploy keys for this thing, and that's why they're getting hacked. So there's a much better attack surface against a bridge than there is against these L2s or the L1s. So that's the blog post. So I just got to put that into pictures and words, and that'll be the blog.